I'm Michelle Giroux with the Rural Wireless Association, and we're a trade association based in Washington, D.C. that represents wireless providers under 100,000 subscribers. Our presenter today is Ronald Mao, Director of Carrier Solutions at Baicells Technologies North America. He is responsible for technical and solution sales. Ronald has over 20 years of experience in the industry. His customers include carriers, enterprises, OEM partners, and WISPs. In the area of Open RAN, Ronald has been driving product innovation and commercialization in both 4G LTE and 5G NR. I have a couple of quick items to cover and we'll get started. We encourage you to unmute and ask questions throughout the webinar. Just remember to unmute. Your presenter welcomes the interaction. You can also type questions into the chat box. You can address them to me or to everyone, and Ronald will answer them at the end of the webinar. The chat button is at the bottom of your screen. This conference is being recorded March 10, 2021, and will be available on the RWA website and in our member newsletter. Ronald, over to you.
Thank you, Michelle, for the introduction. This is Ronald. This is my pleasure to share the Open RAN development or technologies with the audience of RWA. I hope you guys are having a good day so far on Wednesday, and appreciate your taking your time for this webinar. Moving on, today I would like to cover Open RAN in four subjects. The first one, I will introduce Open RAN with its basics. And secondly, I will explain the Open RAN architecture, identify all the components in Open RAN. And thirdly, I will explain the Open RAN ecosystems, as Open RAN requires an ecosystem to grow. And lastly, I will give you an update on the Open RAN deployment. Well, let's come to the basics. Open RAN is all about RAN or radio access networks. If you have worked with Baicells product, you should be familiar with this picture. In radio access network is part of the wireless network solutions. It is sitting in the middle, primarily consists of base stations. On the left is the devices, and they can be a customer premise equipment or smartphones. And on the right, there are core networks, and the Baicells provides the virtualized core solutions that can be either hosted in the cloud or it can be deployed locally. Baicells takes pride in providing cost effective and easy to operate solutions. Baicells has already changed the game of the wireless communications by deploying this small cells for especially for rural operators and WISP customers who requires a low entrance barrier in deploying networks. And we see Open RAN as another chance of changing the game of wireless communications. And Open RAN has been around for a while. You can actually find a lot of information on the internet or while talking with your customers or vendors. But today, I would like to provide a vendor's view of the Open RAN. Okay, so why open? So far, before Open RAN, a RAN is pretty much a closed RAN, right? Open RAN is talking with the respective of a closed RAN. A closed RAN meaning that a RAN that you have is pretty much like a black box. You don't see what is inside, and you cannot do much about it either. And Open RAN is trying to open up the RAN so that you can do a lot of things to achieve different objectives. So how do you see the RAN functions being split? I think there are basically two ways to split it. One is on a protocol stack level, as you can see from the left. A RAN can host functions in RF, layer 1, layer 2, and layer 3. These are the oversimplification of the network protocol stack as far as wireless communications is concerned. For example, layer 2 MAC, actually in a wireless communication, there's more than just MAC functions. But this is a simplification of how Open RAN functions were split on a protocol stack layer. And on the right, you can see that Open RAN can also be split into different planes. There is a user plane where user traffic is flowing. There is a control plane where authentications, controls of the RANs were taking place. There is a management planes that you can manage and operate the network. And there is also a signaling planes that you manage the signaling of the RAN. Why do you split in this on a plane levels? It is because by splitting them, you can terminate different planes at different layers and provide you flexibility. For example, local breakout is a good example of such a user plane and control plane split, meaning that you can locally route your traffic at the RAN layer and while have a control or management plane in the cloud. So there are, by splitting these functions, you have the flexibilities to deploy different functions at different locations. Typically, when your resources are consolidated or centralized in a centralized location, the resources are better utilized, right? On the other hand, when you locate your resources towards the edge, and you get a better performances when, such as you will achieve low latencies. So it depends on your different application scenarios. You may want to split them and locate them differently. That Open RAN gives you this flexibility. Now, what are the tools to build Open RAN? There are tools to help you to do functional split, as I have introduced in the previous slides. And this functional split give you the RAN, the flexibilities to locate different resources at different locations and to meet different business criteria. And the second tool is the virtualization. By virtualize your software functions, you can decouple your softwares from the hardwares, and that can further lower the cost of your RAN network. The third tool is the open source. That is one of the objectives that Open RAN would like to achieve, which is to invite more vendors or service providers to provide functions or intelligence to the RAN network, invite more vendors into this ecosystem. And lastly is the security tools. And Open RAN provides a higher level of security because the fact that RAN network has been broken down into different components, so that if individual components has a security risk. You can easily fix it and or even replace it, change it out without too much impact on your network operation. All these tools will help you to achieve the Open RAN to be open, intelligent, agile, and interoperable. This slides, I would like to introduce the further introduce the benefits of Open RAN. Open RAN is essential to 5G. Open RAN is often talked or discussed with the combination of 5G. Why is that? Why is 5G a big driver of Open RAN? I think there are these perspectives to consider. One is that the 5G Open RAN has a large range of frequency spectrums. For example, in the US, we have this 20 gig, 37 gig, and 39 gig or millimeter waves for 5G services. In Asia, the sub-6 gig or mid-range frequencies are popular, such as 2.6 and 4.9. And in Europe, 3.5 is one frequencies to work with. And in Japan, there are 37.7, 4.5, and 28 gig. And with the higher frequencies, comes with the high propagation loss. As we all know that the higher the frequency, the poorer the RF performance is. And because of that, we have the average 5G devices will consumes more powers, leads to a shorter battery life time. And lastly, because of the 5G's high frequency spectrum that the devices are working with, the average numbers of base stations required to cover a 5G network is bigger than for 4G compared to 4G. For example, the number of macro cells will be up to 1.5 times more than 4G to provide the same coverage. For small cell coverage, that number is even bigger. The research has shown that the number of small cells to provide the same coverage of 4G is going to be 2 times more. So the cost of 5G is an important factor. In order to make 5G deployment economical, we have to do something about it. And there are more. 5G is supposed to provide more services. The triangle on the left shows that the 5G can increase the data throughput with the eMBB or evolved mobile broadband capabilities. It can further reduce the latencies with this URLLC or ultra reliable low latency connectivity. And the MMTC or massive machine type communications to provide IoT services with large number of connections. 5G will for sure introduce more services. And 5G must be an open network to enable those services. Open RAN is a alliance that is helping the 5G technologies to meet those goals. Open RAN is not the 5G, the 3GG organizers actually has already done the works in open up the RAN by for example, splitting the functionalities between, for example, the baseband has been split into DU and CU, but however, Open RAN is trying to enhance that standardization by open up more interfaces and inviting more players into this ecosystem. So the openness and innovation and collaboration is the objective of Open RAN. Open RAN is defining this open, intelligent, and virtualization and interoperabilities as their main objectives to meet. To summarize, the Open RAN is inviting both the traditional and innovative vendors who can complement with each other to promote openness and cross-domain collaboration. Okay. In this slide, I would like to explain the evolution of the Open RAN concept, how it gets started and how it's getting evolved and matured. A traditional RAN, as we have seen before, is a closed RAN. The baseband functions and the radio functions are placed pretty much in a black box that are that you have to install on a cell site. Right? The first movement of the first step of the Open RAN is the movement of the Cloud RAN, where you split the baseband functions from the radio functions so that you can centralize the baseband capabilities in a centralized location, such as in a switch room. The objectives of that configuration is that you can put all the baseband resources together to provide high level of resource utilization. But the price of that architecture is that you would have a very good, you would need a very good transport capabilities between the baseband and the radios, right? And the flexibilities are very limited. So the next step is the Open RAN, where the 3GPP organization has split the baseband functions into CU, which stands for central unit, and DU, which stands for the distributed unit. And between the DU and RU, there is a front haul. And between the DU and CU, there is a mid haul. Typically, a CU is a centralized unit that is placed in a switch room, while the DU can be placed relatively closer to the radios. Bear in mind, in this architecture, 3GPP does not specifically like have the open standards on this front haul or mid hauls. And also, virtualization is not mandatory. It is still likely that when you see an Open RAN, the software and hardware are tightly coupled, and the interfaces are not quite open, so that you may not have the flexibility to choose different vendors to construct a Open RAN network in such a architecture. So the next step is to solve the problem just like that. So the Baicells is a member of the at the ORAN, and which promotes two dimensions of openness. The first dimension is the disaggregation of the RAN function, which means that software and hardware can be decoupled. By decoupling your software from hardware, you can deploy or use the general purpose platforms as hardware that host your RAN functions, which are virtualized software solutions. And the second dimension is that between those different components, the DU, the CU, and the RU, all the interfaces are open, meaning that the solutions from different vendors can be seamlessly integrated together. For the DU platform, Baicells also have this architecture which utilize the GPP hardwares, which is a server-based versus the PCIe card-based solutions. PCIe card can be developed as an accelerator card to handle the network interfaces, while the server is ideal to process higher level functions. I have introduced a few slides, and I just want to check if there is any question. If not, I will continue. So I have touched upon the different tools of Open RAN, the functional split, the virtualization, the open source solutions, and securities. And I would like to dive a little bit deep into those tools. This slide shows a little more detail of the functional split. A RAN protocol stack is roughly divided into 3 layers. One is the RF layer at the very bottom on the right. This is a function that is working on the RF signals, mostly consists of power amplifier. Typically, this is placed very close to the antenna to reduce the radio propagation loss. And above RF is the phi layer, which does a lot of the radio modulations and beamformings, which is very typical technologies for 5G. And above the phi, there are the layer 2, consists of MAC and the radio link control. And this 2 is seen as a high layer 2 and low layer 2 functions. And above the layer 2 are layer 3. You can see the RRC and the PDCPs are typical functions. They are also considered, can be divided into higher layer and lower layer 3. Okay, when you split functions, the most convenient way to split is between these different layers. When you split the RF layer and the phi layer, that becomes the option 8. When you split, in other words, when you split as lower layer, it has a higher number of split options. When you split at a higher layer, there's a lower number of option numbers. So in the Open RAN, there are 8 split options that are defined, and but the actual split is much more than that, because on each split options there are different flavors or further split split layers. For example, the option 3 split, you will see option 7-1, option 7-2, option 7-3, And with even for option 7-2, there are sub-option A, B, and C. So there are many of them, but I just want to introduce some typical split options. Option 8, again, is the split between RF and Phi. And when you split between layer 1 and layer 2, it becomes option 6, where DU handles the layer 2 and RF functions, and the CU handles the rest. And when you split the layer 2, the higher layer 2 and lower layer 2, that becomes option number 2. Right? Within the DU, you can further split at the layer 1 between upper layer 1 and lower layer 2, and that is becomes option 7. Open RAN is focusing on option 7 because option 7 has the benefit of simplifies the RU devices so that you can move many RAN functions, including the upper layer 1 functions, into a DU, which can be placed relatively away from the tower in centralized locations such as a data center. And the benefit of this arrangement is that you can introduce new features much quickly because you do not have to upgrade each and every RU for that purpose. Another thing I would like to introduce is the interface between the radio unit and the distributed unit. In option 8, the interface is defined as a CPRI, the Common Public Radio Interface. This is a traditional fiber interface that transport the radio signals between the baseband and the radio unit. This is a legacy technologies. In 5G, there is a new interface that has been introduced, which is enhanced CPRI. This technology will create the interface efficiency by reduce the traffic load tenfold. In other words, the eCPRI is like roughly 10 times as efficient as CPRI. It is particularly important when you are open up the interfaces between on a Phi layer, which is option 7. Okay. Now I'm moving to the next slide. The next slide explains the virtualization, which is the another tool to build a Open RAN solution. Traditionally, the RAN hardwares are purpose-built, meaning that softwares and hardwares are tightly coupled or bundled. When you buy a RAN solutions, you have to buy the software together with the hardware. That is not a very flexible solution for Open RAN because the objective of Open RAN is to decouple them so that you can introduce more vendors, hardware or software, to into this Open RAN ecosystem. This virtualization is built upon those standalone hardwares with the resources that can provide RAN computing RF, front haul and acceleration capabilities, both for RRU and DU. And these hardwares are served by the virtualization infrastructures that can support virtualized RAN functions in RRU or DU or CU through a network functional virtualization interface. The management or operation of this virtualized architecture has also evolved. Rather than having a consolidated or integrated network manager, we would see that management and network orchestration takes the place of the network manager. It is built on a cloud. It is a cloud-based solutions for management and orchestration. So the core becomes virtual as well. After we've seen those tools to build Open RAN, I would like to look at the ORAN organization in a little bit more details. ORAN Alliances has 8 work groups working on different perspectives of this Open RAN architecture. The first group is the work group is the use case and overall architecture group, which defines the overall architecture of Open RAN as I shown in the middle. In the middle, you can see the dotted boxes are the Open RAN. It has the layers of RU, the layers of DU, the layers of CU. And between Open RAN DU and Open RAN RU, there is this open front haul, which is typically specified by the split option number 7. And between the DU and the CU, it is an interface marked by F1. This is the mid haul. And within the CU, you will see that the control plane and user plane split. And those 2 planes are the interface were standardized by interface of E1. The management of ORAN is accomplished by the concept of RAN Intelligence Controller, or RIC. The RIC is distributed between the RAN and the orchestration and automation functions. They are interfaced through a interface which is standardized by A1. The RIC function on the CU is a near real-time control, which provides lower frequency, lower latencies. And the RIC control on the management layer is non-real-time control, which typically are configurations and performance management services. The non-real-time RAN intelligence controller and A1 interface has its own work groups to deal with, and so is the near real-time RIC functionality. And the front haul, same thing. Front haul has its own work groups to specify the standards, and the rest of the standards were lumped together at a open F1, W1, E1, and X1, XN interface groups. The cloudification or orchestration work groups is concentrated, as its name shows for the cloud-based orchestration. And the white box hardware group is focused on having a white box hardwares to host the RAN functions. By the way, Baicells is very active in the ORAN organization and chairs the white box hardware work groups. And last work group, but not least, is the stack reference design, which defines the reference architectures for all the protocol stacks. Besides the ORAN Alliance, there are another very important organization in the Open RAN ecosystem that is managing the Open RAN evolution. This organization is led by Facebook as the Telecom Infrastructure Project. The TIP organization sees the ORAN life cycle into 6 phases, right? The first phase is the interface specification, which is the focus of the 3GPP standards body and the ORAN Alliance. And the second phase would be create common requirements for the profiles of Open RAN services. It needs a good collaborations of carriers or operators. The operators are coming from both the traditional world and the innovative world that who can provide different perspectives and experiences in building an Open RAN that can be a convergence of the communications world and the IT world. And the third phase is to invite vendors, as many as possible, to participate, right? The more vendors participate, the more healthy competitions we can have to build this ecosystem. These vendors include both hardware and software. For the software, it's especially important to bring in the open source software vendors so that whatever been developed is it was shared at its maximum. Most recently, the Open Network Foundation has joined the TIP project to provide their software-defined RAN solutions. The next phase is the test and validation. ORAN and TIP has jointly built an open test and integration centers that bring in the solutions from different vendors and to verify their functions, compliance, and interoperabilities. And the next phase would be the field trials and deployment. This is an ongoing effort. We have live trials of Open RAN in the working as we speak. And the last phase would be after we successfully accomplish all the 5 phases, the TIP project will promote its adoption and proliferation. In a nutshell, the TIP ensures the compliance and interoperabilities of the Open RAN solution. I would like to say something about the Baicells' involvement in this Open RAN evolution. Baicells is a founding member of the TIP organization, led by Facebook. Excuse me. Baicells is also a very active partner at ORAN. Like I said, we chair one of the work groups for the development of white box solutions. Baicells work with mobile operators in both the 4G and 5G generations of network operations by introducing the white box-based indoor small cell solutions with the China Mobile. And also we have commercial Open RAN products that Vodafone is getting ready to deploy. So Baicells partners with the standards bodies, operators, over-the-top software and hardware vendors, and we see we pride ourselves as a key part of the ecosystem. Baicells has recently announced a Open RAN partnership with at the Even Start program. Even Start is promoting Open RAN to reach out to the rural areas, to the underserved communities, to reach out the peoples who are not quite connected to the internet. And in other part of the world, there's a large populations who needs internet services. Even in the US, we have a certain amount of communities who are still struggling to have reliable internet services. This COVID pandemic has actually exposed that digital divide problems, as we can, we all experience a surge of the fixed wireless connectivity demand in the past year. So Baicells is very happy to participate in this Even Start program to to bridge the digital divide worldwide. I actually have come to the last slide of my Open RAN introduction. The last slide I would like to introduce a starter kit that Baicells are putting together to help operators, small and large, that who would like to trial the Open RAN solutions. This starter kit consists of all the components end to end to let you set up a Open RAN network. The network components consists of CU, DU, the 5G next generation core, the RRU in the sub-6 gigahertz frequency band, and a 5G devices that to complete the network. This starter kit can be configured into as a 4G solution or 5G solution. And you have the options to go straight into the 5G, or you can have the option to go into 4G and later upgrade to 5G. The motivation of this flexibility is that many people have seen the advantages of Open RAN, and they do not want to wait for 5G in order to take advantage of it. The Even Start program I have introduced in the last slides is doing just like that. Even Start program is actually deploying the Open RAN in LTE and will later be upgraded to 5G. So the takeaway from this is that you don't have to wait for 5G to get the benefit of Open RAN. I have completed of all the slides I have prepared for this presentation. And to summarize, the Open RAN is essential to 5G. And Open RAN is open, intelligent, agile, and interoperable. Open RAN deployment is underway. It is something that is happening now, and it is not something that we're just talking about. And 5G and Baicells is enable Open RAN in both LTE and 5G generations of wireless communications. It is available today. With that, I will conclude my presentation, and I invite everyone to ask me questions.
Ronald, I think you may have covered it thoroughly and clearly.
All right, so if there is no questions, I would like to give back the 15 minutes we saved to your live on Wednesday.
Ronald, thank you very much. We appreciate this presentation. It's very helpful.
Thank you, Michelle.
So this concludes the webinar for today. You can visit ruralwireless.org webinar page next week to access the recording and his PowerPoint slides. So we thank you for your participation and attendance.